Meow 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 meow.
Hello, and welcome to another episode of the Super Circuit Bending Super Show. On this episode, we're going to take a look at bending this effects unit, the Yamaha REX50. The reason I've chosen to go with this one for episode 2, in the first episode, we focused mostly on modding things, adding in boards, things that are more applicable to modern hardware toys that you can find. This piece is something that's still a bit more affordable, but allows us to get into kind of what I would think of more as traditional circuit bending, where we're building patch bays, finding good points to create glitches, things like that. And we'll probably do some modding as well. From what I've heard, clock modding this particular device is actually really good. So we'll probably do some familiar ground as well. In addition to that, my other goal for this video is to kind of get the times under control a little bit. I know the first episode ran a little bit long, and I feel like a more appropriate time would be maybe about an hour per part. Sometimes it'll be shorter, sometimes it'll be longer. Just rough guidelines, maybe an hour. Because the 2.5, 3.5 hour videos were, that's a little much. But they were also the first ones where I had a lot to yap about, so that's my excuse anyway. But yeah, I think that'll be a better timeline. And so I think for this episode, we'll break it up into at least 2 different parts, where the first one is more exploratory. We open this guy up, check out all the bend points, figure out what we're going to do. And then the next part, or maybe 2, depending on what all we find in here, will be devoted towards actually installing everything. So this will be a 2 or 3-parter probably, depending on how many bends we find. If anyone's not familiar, the REX50 is actually an interesting little digital effects unit. It's kind of somewhere between a guitar pedal and like a synth rack mount unit effects processor. Apparently it shares some chips with a really popular Yamaha rack mount unit that I'm not super familiar with, but when I was doing my homework, I know a few people mentioned that. And the other thing I read up on is this one apparently responds pretty well to a RAM mod. So I thought that would be a good example too, because that's really similar to what you do on like a Casio SK. So more on that once we get inside and start working on it. But just a couple of quick, housekeeping things before we dive right in. First off, if learning how to circuit bend, watching these kind of long-form videos you think is helpful, it is a tremendous help if you give the video a like and subscribe to the channel. I know it's cliche as hell, I hate asking, but it does help a tremendous amount, not just for pleasing the algorithm, but I'm a small enough channel, I see all the likes and views and things like that come in, and it's really motivating to see when that happens. So it helps keep me motivated to keep making videos. It encourages the YouTube to show them to people. It's just a big help all around, and best of all, it's free. So glad I don't have to ask anyone for money for anything. Just that. The other thing I mentioned in my other videos, but just in case this is your first one, the Super Circuit Bending Super Show, I show the whole process in real time, with minimal editing. So there's kind of a lot of basically just a lot of footage as I go through the whole process. And the goal behind that is just to kind of take away some of the mystique of what happens off camera, and my hope is that it makes things much more approachable to folks looking to get into circuit bending, maybe who have been in it for a while but just want to get a second pair of eyes, see how someone else does it, to kind of learn and think about their own techniques. And I hope as time goes on, people will start sharing those in the comments, and that'll be a good community of folks willing to share their knowledge and expertise that we built here. So that's the main premise of this series. Just to recap that. And finally, the last housekeeping item. I try to mention it in all my videos, but long story short, I have a goofy hand that's really wobbly. So you will see, A, not only my goofy wobbly hand, but B, you'll see some really bad soldering technique in these videos. So I'm aware that it's incorrect, and I just want to make sure everyone else is aware that it's incorrect. The way I solder is a response to only having the one hand to work with, really. So don't imitate me if you're just learning to solder and trying to figure that out. I'm not a great example to go by. And the other thing is, since it is the result of a stroke I had last year, it is illegal to make fun of me. And just want to make sure everyone knows, because I hate for, someone to end up in jail because they, made fun of me on the internet and didn't realize it was a brain damage thing. So I think before we go in, I'm really bad about this, but we'll take a kind of a before shot, if you will, and just kind of show off what this thing is like. So off screen here, because I couldn't find anything small enough to fit all in one screen, but off screen I've got my handy Meowsic that we bent in the first episode, and I've got that running into the REX50. I've got it going in mono, and then coming out stereo. One of the cool things about this unit is that it does support stereo in and out, and it does allow you to apply stereo effects to a mono signal, as we'll see. So let's fire this thing up. Good, I'm glad the LCD is coming through on camera. I was kind of worried about it, because it's the old school type. So first I'm going to bypass it. You can tell when the signal's bypassed because you get this B that shows up on the screen. Alright, so this is what it sounds like without any effects. And if I engage the effects,
little kitty, for the housekeeping meow. All it can say now, all it can say now is and wow.
I'm actually going to put a set of headphones on. I don't usually, but it'd be good to be able to hear this. Alright, so you can hear there, just an example of this distortion chorus patch, and I think it's best if I just try to separate talking and playing rather than trying to balance the audio for both. But this thing has, I forget how many, 90 different presets. The first 30, I think, are like locked-in factory presets that you can't change. But the rest of them you can save as custom patches, which is pretty interesting. So there's this Terminator effect. So how it works is you choose from memory a memory slot. So in this case, memory slot 90. Then you hit recall to load it in, which makes the number stop blinking. And then you can either bypass it or activate it. So bypassed. So you can hear this thing has some really goofy lo-fi pitch shifting, which is really interesting. It's also got a bunch of really fantastic plate reverb on this thing. So. So you can hear those reverbs are fantastic. And apparently a clock mod on this will let you really expand the echo time on the choruses, reverbs, etc. So here's one of the stereo effects I mentioned earlier.
How much is that kitty in the window? The one with the spotted ear.
So yeah, that's just a quick demo of what this thing sounds like before we break into it. As you can see, a pretty fantastic 80s lo-fi budget unit, so I think it makes it a really good candidate for circuit bending. The main hesitation I've had about circuit bending this thing, as you can see, it's got a power cord just built in, so there's pretty much no way to get around using wall AC power. So the first thing we're going to do when I open this up is identify where the high voltage is coming in, and just make sure we stay the heck away from that. Because yeah, I don't want to get zapped. As a general rule of thumb, it's good to just stay away from anything AC. In this case, I'm making an exception just because this is such an interesting unit, and I've worked enough around stuff that has AC inputs that I've started to feel more comfortable with it. But it's definitely something worth talking about, especially as a kind of a segment that's targeted towards beginners or intermediate folks. The last thing I want to do is tell people bad info that gets them electrocuted. That's no fun. Next up, you all may have seen me fiddling with this earlier, but we have this input level knob. Basically just need to pull that off until I think I do need to pull these screws as well. I think those are the same size, but I'm going to set them in a separate bucket anyway. And I just realized, in spite of all that yapping about safety, I had that plugged in. That is a good note. Don't do what I just did, and remember to actually unplug things before you start taking them apart, because you'll still have live power running in, ahead of the switch. And especially during the part where you're taking it apart and you don't really know what's inside of here. You just want to be real careful about that. While we're looking at the back panel, another reason this unit would be really fun and is really good for synths, as you can see, it can accept MIDI commands to change patches. It's got, as we talked about before, stereo or mono options, as well as foot switches to control either the bypass or change patches. So, even for a little cheapo unit, it has a bunch of interesting features to it. I like to hear crackling noises, but I think that was just basically the result of gunk. As you can see here, this shielding plate, I just note this is fantastic. That's super heavy duty. So you get this metal support / shielding plate, and then this plastic piece that goes over it. And well, I said it was just gunk, but now I'm seeing, I think, some of the plastic clips on this cover actually may have broken when I opened that up. Looks like 2 of the side screws do hold it in place, so hopefully that'll be enough. Plus the clips that are still there. But yeah, that's the risk of these old plastic things sometimes. They've just gotten brittle with age, and even I wasn't throwing a whole lot of force on there or anything, but still managed to damage it. Let's set them aside and take a look at what's in here. So first off, like I mentioned, we do have AC power coming in. And long story short, we are just going to stay far away from this area of the board while we do our thing. We're just going to try not to mess with it. Especially this big transformer. That's the one that can really use that. Yeah, good. Again, a handy rule of thumb. Would love to hear other folks' thoughts. But a good rule of thumb for AC is the bigger the pieces are, the more likely they are to be, like AC high voltage components. So these great big capacitors, all that stuff. We're just going to stay away from any of the big stuff, and we're going to focus all our efforts over here on the smaller components. Also got some trim pots. This one is labeled as offset, DA and AD. So, not super sure what those mean. But one interesting thing will be just to kind of check in and see what changing them does. If you find trim pots do interesting stuff, sometimes you can run just wires to these and then add an external knob to let you adjust the value. So those are a good thing to look out for when you're looking for bins. Sometimes if just turning these trim pots is interesting, just running a surface potentiometer off of one of those is a great way to find a bin. Next, I'm going to see about removing this to get at the bottom of the board. If it turns out to be a little too sketchy, we might just stick to the top of the board. The bottom of the board is nice because we can get a better look at traces. Plus, it's much easier to solder things too. You don't have to worry about accidentally damaging an IC. Especially on this older stuff, where if you do damage an IC, odds are that's it. The thing is probably pretty much cooked at that point. Oh, there's one more screw. And the other thing I was looking for, I think this may be right here, is just to see where we might have an oscillator for the clock. And it looks like this is marked with megahertz. It's super tiny. Yeah, I figured it'd be too tiny to get a shot, but you can see from those markings it looks like it's labeled as 4 megahertz. Basically, to remove the board, I do need to remove this plug from its little notch. It looks like the way you're supposed to do that is just to bend this out. Feels very wrong to do, but it seems to have worked. Oops, there was an extra screw hiding under all that. Now, we can actually get a look at the back. So just as a reminder, this area of the board, that's the danger zone. We are going to be staying far away from that. Interesting, I was not expecting there to be components on this side, but there's actually some surface mount stuff on the back here. basically what I'm doing here is I'm using the conductive end of one of these clips to just cross contacts that are next to each other. Usually data lines will be like right next to each other. So it can be a good way to kind of quickly assess which chips you want to pay more attention to because they do interesting things. The downside would be you don't want to cross, like a power into a ground and short something out. Sometimes people will do this using like a small amount of resistance just to keep from doing just a straight short. But this seems like a pretty durable guy. Interesting. I've got a low battery warning, so I'll have to change the battery while we're doing this for the memory. Interesting. Crashed there. And that's something you'll see often while doing this. So it seems like this may be the bank of RAM I've heard people talking about. So far, that's been the most interesting response. Seems like these are controllers. This, I'm guessing, is probably the main CPU. Just based on you kind of know if you found the main the main CPU, because it'll crash like a lot when you poke around it. So I think these guys are kind of our most promising lead. So the board turned over here, and we can see where all of those are. The first thing I want to do is kind of trace out where power is, because I mentioned before, what we don't want to do is accidentally grab power and end up cooking something. So to that end, I'm going to get my multimeter out here. Around there. Okay, and I was checking these voltage regulators because I was like pretty darn sure I could kind of find a voltage coming out of those. Now these, I'm guessing this capacitor is here to stabilize power. Okay, yeah, so this pin here, the kind of bottom left one for each of these, that is going to be hot. And I can tell that because it was coming in at 4.93. The other giveaway that I mentioned is this little capacitor. Typically, if you see a pad that's big like this, it's going to be a ground pad. So seeing this capacitor going from a small pad onto a big pad is typically a clue that that's a filtering capacitor to smooth out a power supply. And since these are memory chips, obviously it would make sense you'd want to have a nice smooth supply for those. That was kind of my tip-off. This pin that's connected to that same pad, basically this guy here. You can see it's connected to that end, the non-ground into the capacitor. That was what clued me off that was probably the power pin. So what I'm going to do is use a red Sharpie just to mark that pin on each one of these. Hopefully that will be a sufficient reminder to myself to stay the heck away from those. I'm not sure if I mentioned it in the last video, but these little paint markers, they're basically, I'm not trying to drop name brands or anything, but these are basically like Bic's version of a Sharpie, but they're a little bit closer to a paint marker. So I like them for drawing on circuit boards, and having a big pack with a bunch of different colors comes in a lot of handy for marking out different things right on the circuit board. So highly, highly recommend grabbing some paint markers, something that can draw on circuit boards, even the ones covered in flux like this one. It's really handy. And the other thing I'm going to mark with this black marker, so we can see this big pad going all the way up. This is going to be our ground. And while there's certainly nothing wrong with grounding things out, in fact, grounding out some data pins can have some really interesting effects sometimes. I'll be doing just that here in a second. So I'm marking those because what I don't want to do is if we build a patch bay, I don't want like 4 of the patch bay points to just be different ground points, right? Just like I mentioned a moment ago, the next thing I'm going to do is try grounding some of these pins. So what I've done, I've connected an alligator clip to a ground point. Now I'm connecting that to the end of one of these test leads. So basically anything I poke with this, I'm going to ground. And I wanted to mark out these power sources first, because obviously I do not want to short power to ground. That would be really bad. Super cool. And one of the things I was doing is checking the same points across different ones just to see if they do the same thing.
I once had a cat named Applebee.
So far it does kind of seem that way.
How much is that? No, the one that bothered you. I'll convince my mom to buy. If you would just come over here. I don't want a turtle or a hamster. I don't want a parrot that talks. I want something cute I can cuddle and don't have to take out for a walk.
So I'm going to go ahead and start marking things up. And just to show you, basically, I've just drawn a simple diagram there. I've marked out that connecting the ground and this pin, those ground, create a loop. So I think it'd be interesting to put a dedicated loop switch in here. So basically all the ones except ground on the top do interesting things, except for the one right next to, or sorry, 2 pins away from ground. That one just kind of seems to stop all sound. So what I'm wondering is, would it affect a different effect differently? So I'm going to move away from a reverb. Let's do the stereo flange and see what that does.
Meow, meow, said the cat, purring happily. Caught up the house and so loudly. little kid, the little kitty. Forgot all it can say now, all it can say now is and bow wow. Before my birthday, my daddy gave to me a coon cat and a parakeet. The week before my birthday, my daddy gave to me two fluffy bunnies, a coon cat and a parakeet. The night before my birthday, my daddy gave to me three bobtail coon bunnies, a coon cat and a parakeet. Now I have six kitties and one parakeet. I better keep a lookout so they never meet. I once had a cat named Applebee. He ran away from me. Applebee, Applebee, hear my plea, my little friend Applebee. Please come back to me. Please, that little kitty. Forgot.
Well, that's found us some really interesting points. I'm going to take a quick break to let my camera cool down, and we'll pick this back up. Alright, so camera has had a chance to cool down a little bit. Just to recap, what I found so far and my very goofy notation for it. On each of those little memory chips, I found these 3 pins and these 6, 7 pins to be really interesting. So those are 10 different pins that I think will be good for pins. Now this pin was really interesting, but only on the second chip from the bottom. Just interesting. So now I'm curious to try, for instance, this one. It didn't seem to do anything too cool. Try that on all the chips to see if it maybe does something interesting on one of them. And then finally we've got our connection between this and ground to create that loop. That's also super cool. So the next 2 things we're going to try. One, I want to try this pin on all the chips to see if there's one chip where it does something interesting, much like this one. And then after that, the next thing I want to do is start testing, what happens if we, instead of just grounding these pins, what happens if we connect them to each other? And that'll help us decide, do we want to build a patch bay where we can create our own patches of different connections? Or do we maybe just install a bunch of switches that toggle these between being connected or grounded? And what I want to look for here is some sort of reverb plus a distortion. That'll work great. And that way I can hear if the pins do anything different for a distortion effect versus a spatial effect with a reverb. Accidentally almost stuck my bad hand in the area where avoiding that would have not been great. And it's this pin that I'm rechecking all the different chips.
I once had a cat named Applebee. He ran away from me. Applebee, 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 hear my plea, my little friend Applebee. Please come back to me.
odd. It almost has an effect when you release it.
How much is that kitty in the window? The one with the spotted ear. I'll convince my mom to buy you if you would just come over here. I don't want a turtle or a hamster. I don't want a parrot that talks. I want something cute I can cuddle and don't have to take out for walks. How much is that pretty in the window? The one that looks so and take you all the way home.
So let's see if that pen does something cool. It seems to mostly affect reverbs, and that's why I didn't catch it earlier. So I've added that into the list of interesting pens. The next thing I want to check is what happens if I start kind of crossing these interesting pins.
Meow, meow, says the cat, purring happily. Cold nose in the house and so lots of
So that's enough for a 14-point patch bay. Yeah, I thought there were some interesting enough effects by crossing the different paths that I'm thinking would go with a patch bay versus a switch setup. And then, of course, have our clock mod in here as well. That's basically how I go about finding bins and getting those mapped out. The last thing I'm going to do before breaking again is I'm just going to measure. When we look at this bracket, we can see that screw hole right down there above the jacks. And that's roughly going to give us an idea of how much clearance we have. Because when I look at this metal shield, that's where the tab is. It sits there. So basically anything we mount, even though there's a plastic sheet on top of this as well, this is going to be the lower portion. So basically, by measuring our clearance up to this little tab, that'll give us an idea of how much clearance we have for controls. And I don't have a fancy, nice calipers. We'll have a depth gauge on the back, but mine don't. But rough guesstimating it came out around 17 millimeters. So to be safe, let's call that 15 millimeters. Let's just double check and see, but I believe that should give us clearance to mount anything we want. What I really want to check is an RCA jack. That is what I like to use for patch bays. Just because RCA cables, you're more likely just to have some around the house, and they're dirt cheap. So I like them, and they're smaller than banana plugs too. Yeah, if I measure from here to the very end, that was pretty much right at 15 millimeters. So that will work. The next segment will basically just be kind of getting everything designed and wired up. So I'm going to break for now and then come back with that. So after taking a few to noodle around and come up with a plan, I think I know what I'm going to do. So here is my very fancy, very easy to read diagram. Here's the map of the chip that we did earlier. Now across this, I've got 14 different points, which we're going to turn into a patch bay. So we can link them up however we like. In addition to just being able to directly connect them, we're also going to put in a switch that will have a diode going between common and then two other points it can swap between. That lets you kind of set something up in advance and then use a switch to turn it on and off. And it also, using the diode, creates like a one-way street. Instead of just blending both the signals, you're just kind of sending one to cover up the other. The other thing we're going to add is a potentiometer that, again, you can patch any of these points into. I'm guessing it'll be a really low resistance potentiometer, since these are little signal pins, but that is something we're going to test here in just a minute. Same thing, we're going to put an LFO in this, and again we're going to have two patch points that you can put in that will be connected up to a Vectral, and then that Vectral, I'm assuming, will have low resistance, but we're going to again test that here in just a few. And then, just like we did in episode 1 with the Meowsic, we're going to have a clock mod with the LFO controlling it. But one thing I did not show in that video is how I come up with the values to use for trim resistors and potentiometers and all that good stuff. So, I'm going to skip over the details of building these super in-depth, since I think that's pretty well covered in the Meowsic episode. But what I am going to do is show how I test out, what values to approximate a factoral, as well as how to figure out what values for the potentiometer and trim resistor for the clock mod. So what I've got rigged up on this little board, this is just my test setup. It's basically one of my clock monitor boards, but I've got it set up to some headers here, a little Arduino that I'm literally just using as a power supply to give it 5 volts. Since we're going to be taking 5 volts off this board, it should be just about the same. If you didn't have one of these, that would be fine. You would just grab power off the board like we're going to do for the real deal. And then I've got this little header thing here with my clip for the clock signal coming out of the clock monitor. And I've got it preset with a 100K potentiometer and a 4.7K trim resistor. Those are good kind of rough guesstimate values to start something off with, I've found. That was really weird. So, after having a minute to refresh, what I did was reread the datasheet for the 1799 and verified that, yes, that div pin should be grounded to give us the correct range. That doesn't really explain why we weren't getting really any, adjustment type behavior out of it. And I believe that the reason for that is because we were trying to basically slap it on top of the existing clock signal, which works for a lot of devices. For instance, the SK1, the Meowsic, both of those, you don't actually have to disconnect the original clock source. You can just go ahead with the new one. However, this one we may need to disconnect it, is my working theory. So the next thing I'm going to do is remove the bottom contact from that resonator, and we're going to try connecting our external clock there and seeing what happens. I've mentioned this before in other videos, but definitely don't feel like you need a soldering or desoldering gun. I have one because it's super handy, I'm not gonna lie, but you can get by for a very long while just using a solder wick or one of those little pump things. It seems to be moving freely. Oh, that's not good. That actually just broke off, and that's happened to me before. I'm going to manipulate these too much, and then the little legs break off. The good news is, as you can see, there's a teeny little bit of metal. Well, maybe we can't zoom in to show you. You can see it's got these little metal leads here. So we should be able to solder some new leads on there. And I fired up the soldering gun again just because I'm going to go ahead and clear out the other connection hole so that we can connect it easier around it. So since that broke off, no reason to leave it there. Go ahead and solder just a couple pins onto this board, and then try to add a couple leads under here as well, the old oscillator. And that way I can kind of use my alligator clips to try things out. So I'm just going to solder those up. Here comes the fan. Yeah, what I was thinking is I might take one length, try to solder it on like that, and then cut out the middle piece. That might be the easiest way to do this and get everything lined up. I think that is pretty close. Here comes the fan. Now I've got little clip leads that I can use. Just test everything out. So before I go back to testing the clock mod, let's just make sure this thing will work. It's an internal clock. That did not do the trick. The next thing I'm going to try, just because it's been a really long time since I've done testing like this. I've been just wiring things straight into the board. Now I can't remember if maybe I was wrong earlier, and I do need to get you do need to get my power from the same board. So I'm going to go ahead and lodge in some power wires. We're going to need those anyway. So we may as well grab them now. Here comes the fan. The next thing I'm going to try is just to double check the voltage on these and make sure we're getting 5 volts powered on. Maybe I did not pick a good power supply point then. Okay, I see. I soldered on the wrong side of the capacitor for the positive, so I basically just made 2 ground wires. So you can see here, this is my positive pin, and just at a glance I was like, oh, positive pin, this big pad. But actually it's not, it's just this little guy. This big pad is a ground pad. See, because I'm on the wrong end of this itty-bitty filter capacitor. So that's why I'm not getting any voltage, and that's exactly why we checked that. Here comes the fan. So once again, I've got my leads hooked up. I've got plug in the unit. Plugged in, I'm getting 0 volts, which is what I want to see. Now with the unit booted up, I'm getting 5 volts, which is exactly what we want to see. And as the unit powers off, back down to 0 volts. So that means we've found a good place to supply our mods with power. I've now got my clock motherboard being powered by the internal 5 volts. We're going to see if that makes any kind of a difference at all. So first off, just booting normally. So this part of the video may end up being a bit of a jumble, but last night my power, or not really my power, my breaker kept going off, even though I was actually using a lot less power than normal. So it was very weird. But anyway, eventually I just kind of set this aside for the night, so I'm back to it. Basically what was going on is I was really scratching my head over why our clock mod wasn't working, because theoretically this should be very close to a Yamaha, just given the value of that little ceramic resonator that we are replacing with our clock mod. And it occurred to me that at no point had I actually tested this red clock mod unit that I used to use for testing, and it occurred to me that I hadn't actually used that in years and years. I haven't done a red ones in a very long time. So I tested it out on a Meowsic that I had laying around, and lo and behold, that clock chip is actually dead. I probably breadboarded it wrong at some point and cooked it, or I'm bad about just throwing my test components in a bucket, so not exactly the most static safe thing. So that's probably what happened. Anyway, I've got a new clock monitor chip set up in our test board. I've got it connected up to the board power. That way when we tune it, we know we're using the same power source that we will be using. The Arduino works great for testing, but since we'd already wired in power wires, we may as well use the real thing. And right now I've got it set up with no trim resistor, just a 250K to jump. So what we're going to do is make sure it boots up with this thing roughly in the middle. Then we're going to adjust the clock as high as we can to see when it starts to crash and falter. And we're going to measure how much resistance that was, and that'll give us a ballpark for what our trim resistor needs to look like. And then we'll start with that ballpark and kind of fine tune from there until we've got a setup we're happy with. And let's see if it boots. Already a very good sign. That's good. Okay, and that's much better. So you can see we're actually getting a response that are changing the clock value, unlike what I was getting before. So that is excellent news that it's actually working now. So now, like I just said, we're going to dial this as close as we can to crashing and take a measurement there. Alright, now I'm going to call that a crash, as we stopped hearing the effect, and we jumbled up our LCD there. So let me see if we'll boot at this value. Not. So turn it down a little bit. And we're booting again. So now what I'm going to do is take our potentiometer out, and I'm just going to measure the resistance between these two pins, since that's what I was using. And I'll even do it where you guys can see. Okay, so we are at 6.6 kilograms. I actually happen to have 3.3K. So let's try 2 of these in series. And since I don't, think anyone needs to know electrical engineering or anything like that to be able to circuit bend, just a little explanation. So series is basically electronics terms for when things are connected end to end. Like so, we go through this resistor, then through this resistor. The resistance between these 2 points is, basically they just add up. So 2 3.3K resistors will add up to 6.6K. Now if you put them in parallel, meaning they're kind of stacked up like this, there's a special math formula for how they calculate out, and I won't pretend like I know that offhand. A real electrical engineer would, but I do not. There's online calculators for parallel resistors. I always use that if I need to get to some odd value that I can't just add up to. So I'm going to stick with our 250K pump for now. And I'll try it with the 6.6K trim resistor and see if that protects us against crashing. Alright, we're booting, so that's good. So we did still crash. And we can't boot when it's turned all the way up. I'm going to replace one of these 3.3Ks with a 4.7K. So that should give us a total of 8K. Which means we should be able to get pretty close to the crash point and still be protected from crashing. You know?
Little kitty, for the housing now. All in the day now, all in the day now. And how loud. Come on, before my birthday, my daddy gave me a young cat and a parrot. For my birthday, my daddy gave me two cookie bunnies, a young cat and a parrot. The day before my birthday, my daddy gave me 3 oddtails, 2 bunnies, a young cat and a parrot. Now I have 2 kitties and 1 parrot. I better keep a lookout so they never meet.
So going all the way up to 250K, I don't know how well it translated to the screen, but the LED segment counter started to flicker. And what I was doing at the end there was just trying to listen and hear towards the higher end if adding resistance was like actually making an audible difference. So what I'm going to do is swap out our 250K for 1 mega ohm and just crank up the resistance really high. So with the blinking light, I can, you guys can't really see it with the blinking and how it affects the camera, but I'm actually able to still change patches. Some of my button presses don't work, but most of them do. So let's do echo.
How much is that TV in the window? The one with the spotted ears. I'll turn kiss my mom if I do. If you would just come over. I don't want a shirt or a shirt. I don't want a parrot that's hard. I want something that's subtle. And don't have to take out the walking. How much is that in the window? The one that was so alone. I want to take my money and take you away.
And next, I'm just going to test the upper end of resistance here.
Meow, meow, said the cat, purring happily. Caught a mouse in the house and so fast asleep.
So we get a little bit of interaction towards the upper end. The reason I'm checking with a 1 mega ohm is basically the LTC 1799 operates with a resistance between 3 kiloohms and 1 mega ohm. And so basically anything beyond 1 mega ohm just kind of doesn't do anything, even for the chip itself. And then, will the device, even though the frequencies change, will the device do anything different is the other question. So it seems like at the upper end, there's not too much going on with the 1 mega ohm pot. So I'm going to try a 500K pot. See how that does.
Where's our dear boy? Haven't got a clue. Where's our dear boy? Haven't got a clue. Where's our dear boy? Haven't got a clue. The big black cat was hungry. The fish in the fish bowl, what do I do? The fish in the fish bowl, what do I do? The fish in the fish bowl, what do I do? Can the cat people eat through? Oh, they're going for a soup. They're going for a soup. They're going for a soup. The big black cat is full now.
So 500K is much more responsive. It still gives us a really wide range. Control just feels a lot better, and it actually seems like it's doing something at the higher end of the resistance. So that is how we figure out our trim resistor and potentiometer values, just by wiring it up like that and playing around. So just to recap, we found that about 8K for our trim resistor works great, and then an extra 500K on our potentiometer makes for a very nice control range. I'm going to jot that down on our cheat sheet here. So I just noted that down alongside all our other notes. That basically this is some points we're going to hit off of the memory chip. Maybe just the second chip up because it's got this extra cool pin that some of the others don't seem to have. Turn that into our 14-point patch bay. We've got the values that we're going to set up for our clock pot and trim resistor. Now, the next thing we need to look at is we also want our patch bay to be able to hook up to a switch or a potentiometer. Now, I'm guessing for this potentiometer we want a really low value, like 1K is pretty much the lowest. I mean, once you specialty order something, 1K is like the lowest standard potentiometer you can get. So yeah, we're gonna do some quick tests to verify that we do want a low resistance, and go from there. Perfect. So that kind of verifies my expectation. That's the test there, where we just see when I have this turned all the way up, meaning maximum resistance, the glitch was basically not there at all. If somebody disconnected this pin, that was me listening to hear if it changed at all between maximum resistance and no connection at all. And I couldn't hear an audible difference. So that tells me that 1K is enough resistance at max that it's going to prevent any glitch, but as I turn it up, you could hear the glitch starting to come into play. And typically with when you're doing ROM or RAM hacks like this, 1K is all you need. The signal, little signal pins don't have a whole lot of oomph, so it doesn't have to take a lot of resistance to alter those. So that tells us the values we need for a clock modder. It also tells us the value we want for our kind of glitch patches. So let's add that to our notes. And in here, this value is verified. And that's just a little note to myself so that I know I did check this value and it is good. And now, when we put in our LFO, that's going to give us a starting place. We know for our signal back control that we want to patch into, we want something around 1K, is probably the lowest resistance I've got. And then for the pitch bend mod, we want something that goes up to about 500K, 510K, something like that. That will put us in a good spot to guesstimate what we need to use for our back controls when we put those together. And if you're curious about how we build the LFO, I go through the full process in my Meowsic video, episode 1, Super Circuit Knitting Super Show. But I'll show that process here as well, since we've got a couple different values. What I am going to skip over is actually building the LFO board and the clock modder board, just because I think those are thoroughly covered in the other video. No need to waste anyone's time showing that full process again. If you are curious to see that full process, it is completely laid out in the Meowsic videos, and they are broken up into chapters, so you can just kind of jump to the specific portion you're interested in seeing either the LFO circuit or the clock modder build. Oh, there's one more thing I forgot to mention because I did this off camera in the jumble where I kept losing power. But when I was testing the clock mod, you'll notice I have it just connected to this top pin here. So it turns out I was wrong. I initially thought this bottom pin, this is where we needed to inject our clock signal. But I was wrong, it's actually the top pin. And the last thing we need to test before I actually adjourn is to see, can I just inject that clock signal, or do I need to keep, the old clock source fully separated? So first, let's power that on. So basically, I am using the clips, which is on the screen, I'm using the clips to hook up the original clock source. And just verify everything's working normally. Change that just something a little easier here. Okay.
The little kid, for a house meow. All it can say now, all it can say now is and how loud.
As you can see, if I try hooking up my clock mod on top of the existing clock source, we just get a bunch of wacky errors. So when we set this back up, what we're going to need to do is actually physically swap between whether this pin is connected from the original clock source or whether I didn't hear any of that. So what that tells us is, well, we can't just inject the clock signal. We actually have to, we already have removed this, but we would actually have to remove that original resonator, and our switch is going to have to toggle between whether this is connected or whether our clock mod chip is connected. And that was the last thing I just needed to test, so that we know how to wire in our clock mod. And that tells us that we do have to completely separate the two. With a lot of things like SK1s and Meowsics, you can just drop in your new clock signal and it'll overwrite the old one, so to speak. But in this case, we actually do have to completely hijack this connection point and disconnect the old clock completely. Okay. So now that we've got everything planned out, and we've gotten all our different component values tested and sorted out, we've got the pins we want to use for our patch bay mapped out. I think this is a good place to end part 1 of this video. Part 2, I think, will be dedicated to, I'm not sure a good term for it, but I think I'm just going to call it setup, if you will. So basically what we'll be doing is kind of preparing the case, doing a bunch of measurements, showing how I design a case, and how I'm going to mount all the hardware, the considerations that go into that. In the first episode, the Meowsic video, that was a very straightforward, kind of punk rock approach to it, where you just grabbed a drill and went for it. And that's a great way to do things sometimes, but in the case of something a little more sophisticated like this, I want to spend a good amount of time talking through that process, talking about different options, hopefully give you all some ideas, and with any luck, some other folks will share their ideas and what they like to do with us as well. And then finally, in part 3, I'm thinking this will be a 3-part video, but then in the 3rd part, we will kind of do all the actual wiring and putting things together. So as I think I mentioned before, but just in case that got edited out or was in one of the takes I lost with power outages, in this video, I'm not actually going to show building the LFO or clock monitor modules, just because I think I covered that extremely thoroughly in the Meowsic video in episode 1. And that's all marked out with chapters, so you can watch just that part if you're interested in that without watching the whole hours and hours of video. So I'll do that part off camera. So when I say wiring it together, I mean wiring together the various modules, the bin points we mapped out, the controls for the patch bay, kind of doing that final wiring portion, not necessarily showing, building out all the mod boards. But anyway, that's kind of the roadmap, I think, for this project, and that'll do it for this portion. So just wanted to take a moment to say thank you so much to everyone who has already subscribed to the channel and who is following along with these as they come out. It's a tremendous help to see likes and subscribers come in, both in terms of it's a huge help for the channel, and also it's a big motivator for me to see that stuff coming in. So really appreciate it. It's great to see, and if you haven't already, definitely please consider subscribing to the channel. Again, it helps out a ton, and it feels weird to say. I always used to hate hearing that in like every YouTube video, but there's a reason it's there. It's hugely helpful, and it's free to do, so yeah, it's very much appreciated for those who already have, and for those who do after this video as well. Yeah, that's a good place to wrap it up. I will see you all again in part 2, and we will start getting that setup done.